we talk about machine and digital identities, but really they're all digital identities. Digital identity can be issued to a person, a device, an application, a service, a thing, anything that you want to, I guess, uniquely identify. When people think specifically about machine identity, there's this notion that you issue this cryptographic credential to a machine in a data center, and it's used to assert the identity of all of the applications that are running on that device. And really, that's a huge mistake when you consider how attackers could penetrate your network, access a machine through a poorly maintained physical access control system, or even a weak online password, and then they can use the machine's digital identity to launch an attack across your business, or even masquerade and pretend to be you online. So really, when we're talking about the uniqueness of digital identity, and in particular machine identity, you need to take that a step further. Each and every individual within an organization and within life has their own unique identity. We've got driver's licenses, national ID cards, passports that all prove our identity. And the same is true in the digital world. If you're running many business applications, services from a host or a collection of hosts, each of those applications should have and should be able to assert their own identity to prove that application A can talk to application B, as opposed to a generic machine-based identity. So machine, application, device identities are very, very similar, if almost exactly the same as the human counterparts. And I think the use, issuance, management and processes that people wrap around a machine identity in particular, some of those nuances and important criticalities of how we identify a device, application or a thing are lost, where we spend a lot of time verifying the identity of a human being before we issue them with a digital identity. So people should definitely sit up and take note and ensure that those checks that you perform on your users are also equally, where you can, performed on the identity of the application, device, machine or thing counterpart. The selection process, or what you should consider when choosing a digital identity provider, comes down to a few things really, and this is the same irrespective of the type of digital identity you're issuing. So one to a person, one to an application, one to a device, is step back and look at the use case. That's really going to govern or help to govern the direction you take. And one of the first things to ask is, do I need public trust or private trust? So if I'm a person and I'm digitally signing a document and I want that to be legally binding and or trusted in different countries, in different jurisdictions, then that guides me. I need to be buying a publicly trusted credential from a trust service provider that can deal with that for me, and that could be an AATL or a qualified digital signature. So that use case clearly guided me to the type of credential and type of identity provider I need. Versus if you're issuing machine identities to tablet PCs and laptops for you to access your corporate network, then that guides you very squarely to private trust use cases. So an in-house enterprise CA connected to Active Directory, perhaps, where you can issue device credentials. So it really does depend on the use case that you're issuing the identity to fulfill. VPN, access to wired and wireless networks, they're all clearly private trust use cases. Whereas if you want to be able to assert your identity outside of your organization in different locations, different geographies, then you're clearly being guided towards the issue of a credential that's publicly trusted. And there's definitely different processes for you to get those credentials, and obviously cost, though the cost of a publicly trusted credential will be dramatically different to that of a private trust credential. You also got some of the smart home and IoT use cases to consider, where there's a completely new framework of CAs and standards that are being created by the Connectivity Standards Alliance. So those will definitely guide you towards the different types of issuers of credential that exist out there on the internet. So yeah, use cases. What all I do come back to is that definitely governs what type of credential you need and where you would obtain it from. Identity proofing and KYC, or know your customer checks, are critical. They're critical because they protect you, your network, your organization from trusting inadvertently something or someone that's pretending to be somebody else. So in the digital identity use case for devices, it protects you from someone simply plugging a device into a network and begin a transaction. You know, your receptions, your office spaces, they're all open. We work in a world where we're all, for want of a better word, hyper-connected. Someone enters into a building, they can find your wireless network, they can connect to a guest network, and they're on. Equally, if you're in a open plan building, hot desking, even office sharing spaces, you can plug into a networking point and you can start transacting. So the idea here for identity proofing for a machine in particular is that you're able to prove unequivocally where the device came from. The supply chain hopefully can enable you to trace the device back to a manufacturer to prove provenance, which will enable you to then gain information about the device when it was shipped that you can then use to verify its identity during its enrollment process. So much like a person, when I arrive at a registration authority, I present some paperwork that proves I am who I am. So a utility bill, a driver's license, my passport, and that helps the person proving my identity verify that it's me enrolling as opposed to someone who might look like me. And they'll collect information that only I would know that they can verify with an independent source. Devices, applications, when they're created, they often have some verifiable information that you can use that will then enable you to check with some kind of manifest or some kind of purchase order that will enable you to prove the application, the device, or the equipment's identity. So it's critical to ensuring that the identity that you're issuing to a device goes to a device that you actually purchased, as opposed to something that somebody has brought into the office and plugged it in. I mean, this goes back to basic security principles. If you find a USB thumb drive sitting reception on a desk, are you going to automatically plug it into your machine? No, it's untrusted. The same applies to connecting things to your network and simply letting them have unfettered access to whatever they want. Verify the identity, prove that with a verifiable source, and then issue the identity that gives you the privileged access that you need. So identity verification for a device is similar to checking the identity of a real person or a real user. It's the ability to perform identity checks on an application, device, service, using existing information that we know about the equipment, the application, during the vetting process. So for example, if you're able to verify an application or a piece of equipment back through supply chain, you could then potentially verify serial numbers, a checksum on an application, some kind of hash value, a unique hash value for the application, maybe looking right down to a code signing certificate that's been used to sign the application from manufacturer, therefore proving that it's trustworthy. And in some cases, devices, applications sometimes ship with a digital identity that was created during the manufacturing process. So this comes back to zero trust and secure supply chain. These identities are created right in the secure manufacturing facility. They're issued securely to the devices. So once they arrive within your data center, you can then load the trust anchor from the manufacturer, and that identity can then be used as the basis for issuing a replacement credential when the device enters service in your network. So there's a variety of ways where you can unequivocally prove the authenticity of a device, even right back through supply chain. And that's quite important in high trust environments. So once you've gone through this process of securely verifying the authenticity of a device, you've gone to the trouble of making sure that it is from a trusted source, and you are going to issue a digital identity. You need to be able to ensure that you can protect that credential for a prolonged period of time once it's on the device. Devices are not like people. They're not going to lose their badge that gets them into the network or gets them into the building. These are fixed pieces of corporate asset that hopefully don't move too frequently, but nevertheless you have to protect the identity to prevent an attacker or a rogue administrator from stealing it and obviously pretending to be somebody else. So there's a number of standard means that are available. You've got a cryptographically secure FIPS certified USB token or a smart card with a smart card reader, and these are useful, but I would argue that smart cards and USB tokens are probably more geared towards people because they are portable. They can be easily removed by an administrator, or inadvertently knocked out of a reader. So whilst they can be used to protect an identity, I wouldn't necessarily advocate using them for a machine identity. You want something that's a bit more permanent, fixed to perhaps the chassis of the server, the motherboard, or the data center. So then you start looking towards TPM, trusted platform modules that are embedded within a device. They're soldered into the motherboard of a machine and are readily available. They're not terribly expensive. They don't let you perform high volumes of transactions, so they're good for low volume transactions and do provide good methods to protect the identity of a machine. If you're into high transaction environments, then you're going to be leaning more towards the more traditional hardware security module. There's a number of vendors out there that supply you with different form factors of device that can either be embedded within your server in a PCIe slot, or if you have a multitude of applications, network appliances are available. So many applications can share these hardware security modules and the different slots that they offer. They're all FIPS certified, common criteria certified, to ensure that keys are generated in hardware, they never leave the hardware, and only authorized applications and devices can connect and use the keys. So they provide really high levels of security. And there's options, like I say, you've got USB portable options, PCIe that can be inside of your server or appliance, network options, and there are also cloud providers. So depending on the size of your business, the location of your applications, you have a collection of options that are available to you, ranging from USB smart cards, trusted platform modules, all the way up to high-end crypto devices that can be embedded in servers or served from the network or the cloud. So at Ascertia, we build products that enable businesses, governments, and trust service providers to create and manage digital identities, and they're being issued to people, devices, applications, and things. Our trust services platform, ADSS server, and our registration onboarding tool, ADSS Web RA server, have been specifically designed to work in conjunction with existing business applications and processes to enable digital identities to be created for people, devices, and things following a vetting process. So the Web RA server tool has been specifically designed to enable you to enroll, renew, manage digital identity for a broad selection of applications and use cases. So whether you're onboarding a person, a server, or a device, there's an enrollment mechanism and tool there to support you. So we support things like SCEP, CMP, EST, ACME, and Windows native enrollment, as well as a collection of other RESTful APIs that can integrate seamlessly into your current enrollment workflow. Onboarding and vetting is obviously a very crucial part of any trust system. So once identity is proven, trust can be delivered.